Hi and welcome to this section where we are going to look at some relations between the backward difference operator and other differences. So far looked at one with the first forward difference evaluated at y0. By definition we know is y1 minus y0, okay? However, we know that this is the same as the first backward difference evaluated at y1, because the first backward difference evaluated at y1 we said is y1 minus y0. Okay, so in a similar way we can see, well, we already saw that the second forward difference at y0 is given by y2 minus 2y1 plus y0. However, we have again seen that this is the same as the second backward difference evaluated at y2. You can flip back in the notes and check and verify that we derived this and we found it to be this. Okay, so I hope as the pattern goes we can see that the third, we shall not, this may be a little long, but I think we can easily follow that this will be some expression which we had, and it should be able to be the same as the third backward difference at y3. Okay, so you can just follow from 1 and 2 and then, you know, deduce how the pattern for other backward difference, the relation between this and that. So the second relation we would like to see is that the forward difference minus the backward difference is going to give us the forward difference times the backward difference operator. Okay, a proof for it is quite easy to follow. We consider the function f of x, okay, for which we know that the forward difference operator evaluated at f of x by definition is f of x plus h minus f of x. Also we know that the backward difference operator evaluated at f of x by definition we have saying that it is f of x minus f of x minus h. Okay, therefore the first forward difference operator minus the backward difference operator of f of x, okay, is simply going to be, we can expand this and then say first forward f of x minus first backward of f of x. By definition we have said that this is f of x plus h minus f of x, then minus, we have said that this is f of x minus f of x minus h. Okay, so by definition here, okay, there's nothing like by definition, but we can retain this as it is by definition. And then by definition here, if we are also to make it a forward difference here, we see that what we have here, okay, is the first forward difference evaluated at f of x minus h, because the first forward difference evaluated at f of x minus h is going to be f of x minus h plus h, which is f of x, then minus f of x minus h. Okay, and so so we can pull out the delta here, and then we have f of x minus f of x minus h, and then again by definition we know that what we have inside here is the backward difference. This is the forward, and then this is the backward difference at f of x. Remember here we have forward minus backward at f of x, and and then if you look at the right hand side and the left hand side, we can now therefore deduce that the forward minus the backward should be equal to the forward times the backward, because this will cancel. Okay, alright, now the relationship 3 and 4, which are in the notes, are a little ahead because we have not yet looked at the shift operator, but we shall come back and prove them that the backward difference operator is equal to the forward difference operator times the inverse shift operator, and then the backward difference operator equals to 1 minus the inverse shift. So we cannot prove this for now because we have to look at the shift operator. Okay, I will define it in the next video so that we can be able to prove this. So for now, that marks the end of this backward difference operator. The rest of the exercises that in the table, you can simply follow through by filling in the function values. For instance, if you set up this table, the rest you simply have a function y is equals to f of x. So you have the values of x given to you, and you can compute the corresponding values of y and fill in these tables, okay, and then just get the corresponding backward differences that they want. If there is any problem, you can always put in the comment section. So for now, we shall meet in the next video as we look at another difference operator. Thank you and see you.